This is by special request. I'm going to do two sets of these. The first one is going to be out of the Kendall Hunt DG book. For those who are not familiar, it is the blue book that I use in the classroom instead of the green Holt book. Alrighty, so we're going to start off on page 588, and we're going to do 3, 8, 12, and 18. Again, this is by request. Starting off with number 3. So let's go ahead and take a look at 3 here. Here's usually our most important piece of information right here. And I could go ahead, if I was just dealing with straightforward similarity problems, I could start setting up my proportion with PI over SI and so on, IE over IC, and see what can work. But this isn't going to go that way. They're trying to trick us up a little bit. Now I'm given here and here, 40 and 42, and that's going okay, and that's nice. But what else are they giving me? They're giving me point S as the midpoint of this right here, PI. That kind of got cut off a little. Maybe if I can move this over just a tad. PI, okay? And so this and this is the midpoint right here. But guess what? This is also a midpoint. Now another thing is with the similarity is, angles are congruent. So I know that this angle and this angle are going to be congruent because given parallel lines, corresponding angles are congruent. And the converse, giving corresponding angles, then parallel lines. So we're going to use that. And, well, I don't really have to. There's other ways to do this. But the first thing that's starting to pop out in my mind is triangle midsegments. Midpoint, midpoint, parallel line. This is going to be simply using the triangle midsegment definition, and this is just going to be flat out 20. Okay? And guess what? We got a 42 here. We got a midsegment, 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 and corresponding lines, corresponding angles. Boom, boom. I'm going to put it right here and so on. I'm going to have parallel lines again. This is going to be 21. So in short, CL is 21 and CS is going to be 20. Okay? There's other things that we can explore on this triangle, but I'm just going to keep moving on because it is Super Bowl, the game's going on, and chili is done, and cornbread is in the oven. Next. Now, this problem, many students have a problem with because I said, okay, here's your homework. Do investigation number 2, then do the homework. Many of y'all skipped investigation number 2. Investigation number 2 would have taught you that you're dealing with basically an angle bisector opposite side type relationship here, which is this conjecture right here. That is the end of investigation number 2. In short, this is a very straightforward problem. I'm just going to put 40 over 34. Because we're proportional here, is equal to y over 51. Now there's other ways I can set this up. So I just have 51 times 40 over 34 is equal to y. And I can set that in the calculator real quick. My handy dandy Casio right here. And I'm just going to do 51 times 40 divided by 34, and that should get me 60. And that is the correct answer. Yay. Done with that. Okay, 60. Again, review this conjecture and know it. Next. All right, this is a fun one. I enjoyed this problem. This one piqued my interest a little bit. So we're going to go off, okay, what do we have here? Well, I have congruent, congruent, and I have parallel lines. That's important. Well, one of the first things that pops in my mind is, well, parallel lines, transversal, corresponding alternate interior. So this guy is going to be congruent to this one. Okay, so I have this, and this angle congruent. Then I'm going, what else? Well, I got base angles congruent, so that means I have an isosceles triangle. So this right here is X. Now I need to think on some more stuff. I got parallel lines. I have angle, okay, and reflexive property right here. So I have this angle congruent to this angle. I'm going to draw a big one, okay? So I got, because of parallel lines, corresponding angles congruent, and reflexive property right here, I have angle similarity of this triangle, okay, this one right here, and that's going to be X, okay, and the big triangle. Come on, draw me a big triangle, come on. And this is going to be 15, and this is going to be 10. Alrighty, so we can set up a proportion. The only thing is, what do we call this right here? Well, I can say, well, that's just 15 minus x. Alright, so this part right here is 15 minus x. And then I could do apples to apples and oranges to oranges. All right, so I'll do 15 minus x over x is equal to this whole thing 15 over 20. All right, so here we go. 15 minus x, come on little writing pad, over x, come on, it's being evil. It's because the Cowboys aren't in the Super Bowl. X is equal to 15 over 10. I'm just going to call that 3, and that's going to be a 2. So I'm going to have 30x minus 2x, 30 minus 2x is equal to 3x. That is going to give me 5x is equal to 30. And of course, x turns out to be a whopping big 6, which is what the Cowboys needed to get in points on that dropped ball with the Packers game. Alrighty, so here we go. Questions on this? Well, of course you can't ask questions because you're like 50 miles away. Alrighty, or no, 30. That is it on this problem. This is a cool problem. Study this problem. Alrighty, last one. Prove that corresponding angles, similar triangles are proportional to corresponding sides. There's several different ways to do this. I'm just going to walk through it. I'm not going to do the, two-column proof thing. So let's go ahead. Corresponding now to similar triangles. This is the key. We have similar triangles. So I know a couple of tidbits about this. One, similar triangles, all the angles are congruent, right? So this angle is congruent to this one. Yeah, this one's congruent to this one. I won't draw the third one. It's not going to be needed exactly. So the first thing I can notice is, hey, I have triangle 1 right here and triangle 2 right here are similar. See this triangle here and this triangle here? They're similar because of angle, 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 angle. Therefore, given similar triangles, sides are proportional. That includes this here and here. So if we want to do this, come on, A, B, I'm going to hit you, C and D. I'm not holding my writing pad correctly or something. And then M, N, O, P. Alrighty. So I know that given similar triangles, I can do AB over MN is equal to BD over NP, so on. Okay? I could also prove that these two triangles are similar, 3 and 4, all right, for the same thing, angle, 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 angle. This right here is a right angle, 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 angle. I could prove those are. And I could set up the very same proportions, okay? So I can say, okay, NP is proportional to BP. Well, we'll go ahead and do that. NP and BD is equal to BC, sorry. I don't even know what I write. Come on. Going backwards, I did left to right. I mean right to left, so I better have NO over BC, right? And so on. That is how you're going to approach these. Now, again, this wasn't a two-column proof, but it is kind of straightforward once you see the angle-angle relationships. All right? A two-column proof will only be like 4 lines. It will go pretty quick. Well, maybe 5 with all the givens. Okay? Alrighty, so I'm going to end this and upload it to YouTube and email you the link. And any other students who want to see it, it will be my Chapter 7 playlist because it's predominantly Holt on my YouTube channel. And I'll probably have to get Kendall Hunt channel someday, maybe over the summer.